Good day guys, this is your tutor engineer. Today we are continuing with our lesson on motion in one dimension. We'll be doing graphs, so let's start. An athlete runs away from you at a constant velocity of 6 meters per second. After 20 seconds, she turns around and runs back at a velocity of 4 meters per second. Draw a velocity time graph for the first 30 seconds. Okay, let's just maximize. So we'll be dealing with the first 30 seconds. We'll call this time axis. So 30 seconds we can accommodate as 10, 20, 30. And then here it's the velocity axis. So we can say 2, 4, 6, and then likewise on the negative velocity axis. Okay, so the person or the athlete runs for 20 seconds. So that means they will be running at a constant velocity, right? Remember, constant velocity, so it's just going to be the horizontal line. And then at 20 seconds, and then they will turn around, meaning they will change a direction of motion, meaning the next motion would be negative. So they'll turn around and run at 40. Sorry, at 4 meters per second. Okay, so this is the graph of the velocity time for the first 30 seconds. So we are done. Let's go to the second question. 9.2, draw a position time graph for the first 30 seconds for her motion. As we have discussed before, if you are given the velocity time graph and you are asked to calculate the displacement time graph, that means you need to work out the area under the velocity time graph. So now, okay, let's work out the area. This is the area that we'll be using to calculate the displacement after 20 seconds. So let's just work it out. So let's write here. We'll say the displacement at 20 seconds is going to be, since that is a rectangle, you'll notice that the base for our rectangle is 20 seconds, and then the height is 6 meters per second. So the area is going to be base times height. Our base is 20, height is 6, therefore 20 times 6 is 120 meters. So that will be the displacement after 20 seconds. So we'll write here on the time axis, the time axis will remain the same. So we can just count in 30s. So I'll have 30, 60, 90, 120. So the displacement, this is the displacement axis. So after 20 seconds, this is 20 seconds here, the displacement will start at 0, and then it will increase to 120 after 20 seconds. So now let's work out the displacement between 20 and 30 seconds. Likewise, the base would be now 10 seconds, and then the height would be minus 4 meters per second. So let's work out the area of the displacement at 30 seconds. Base times height. The base is 10 seconds. The height is minus 4. So I'll have minus 40. Therefore, since the displacement is cumulative, we'll say the displacement at 30 seconds will be the summation of the first displacement and the second one. So we'll say 120 minus 40, that will be 80 meters. So we're gonna plot 80. So 80 meters, it's about there. So at 30 seconds, the displacement will drop to 80. So here the coordinate will be 30 and 80. There the coordinate is 20 and 120. So that will be the displacement time graph. And then let's go to the second question, or the third question rather. What distance has she covered in 30 seconds? Remember, the displacement is a distance, rather it's a scalar quantity. So the distance, you don't take into account the negative sign. Remember, we calculated the x at 20 as 120 meters, and then the x at 30 is going to be 40 meters. So we're not taking into account the negative sign. So the distance will be the sum of the two, which is going to be 160 meters. So that will be the distance. And then 9.4, what is head displacement after 30 seconds? So we've already established the displacement after 30 seconds. Now the displacement is a vector quantity, which means now you need to take the minus sign into account. So you'll write minus 40, and then you put both of these together, you'll get 80 meters. Remember, you need to write the direction. You can say in the positive direction if you're not given a direction, to indicate that this is a vector quantity. Okay, so that's it for today's lesson. Stay tuned on the next lesson on graphs and motion. I'll see you later, and cheers.